Hi, in this video we're going to see how we can sketch a cubic that is not factorized, that we have to do the factorization ourselves. Now, I suggest you watched a previous video where we sketch cubics where they are in factorized form. But just to kind of recap what we saw, if we have a factor in the factorized form of the cubic of x minus a without any power, then the graph is going to cross the x-axis. So it's going to cross the x-axis at a0. If it's a repeated root, so a repeated factor, sorry, so it's something squared, then we're going to get a root of a. So it touches again, sorry, that should say the x-axis at a0. And finally, if it's cubed, then you're going to get something called a point of inflection at a0, which we'll cover again in a second. Let's look at this. Now, it's not in factorized form. We want those factors so we can apply the theory before. So we need to factorize this. So let's just copy it out. Y equals x cubed plus 7x squared plus 10x. Now, to factorize it, first note that we've got a common factor of x. Always look out for common factors first. So we can take out the x and put a bracket, and then that's going to give us x squared plus 7x plus 10. And then in order to factorize that quadratic in the bracket, we find two numbers which add to give the 7 and times to give the 10. What are those numbers? Well, they're 5 and 2. So therefore, we can factorize it as x times x plus 5, x plus 2. And if you don't know how to factorize quadratics, then you need to watch my videos on that first. Okay, right, so let's look at these. None of these are repeated factors. Nothing is squared here. It's just x without a power. And so if we make each of these 0 to get the roots, that's what we did before, then the roots are going to be, well, if the x is 0, you just get 0. If x plus 5 is 0, then you get minus 5. And if the x plus 2 is 0, you're going to get minus 2. So we explored this earlier. So that's basically going to give us our roots here of 0, minus 5, and minus 2, the x-intercepts. So let's put them in that order, ascending order. That's minus 5, that's minus 2, and that's 0. So we've got A, B, and C. Yeah, we've got minus 5, we've got minus 2, and we've got 0. Now, if this graph didn't cross the origin, but it was just some other point on the y-axis, then what we do is to find the y-intercept, we just make x 0, because anywhere on the y-axis the x is 0, and you sub x is 0 into this. So you do 0 cubed plus 7 times 0 squared plus 10 times 0. Now, in this particular case, the y value would then be 0, but it might be something else in general. Now, we've got this further example here, and we want to factorize again, but this time we've got a sort of like touching point, haven't we? So if we factorize x cubed plus 12x squared plus 36x, if we take out, sorry, that's x there. If we factorize out the x, we get x squared plus 12x plus 36. And now what two numbers add to give 12 and times to give 36? Well, they're 6 and 6. So we're going to get x brackets, x plus 6, and then x plus 6 again. But we could write that as x brackets, x plus 6 squared. Now, let's look at the roots. So the roots are going to be, if y was 0 to get the roots, the x-intercepts, then either x can be 0, so we get 0, or the x plus 6 is 0, in which case we get minus 6. Now, this x here is not a repeated factor, it's not squared, so you get a cross at this root, and this x plus 6 is squared, so it's a repeated factor, so you get a touch at the minus 6. So if we look at that, we get a touch at the minus 6. Yeah, look, the graph touches the x-axis at minus 6, and you get a cross at the 0. And so that's our A and B. We've got minus 6 and 0. And we are done.